cielos son negros que me alcanzaron a ver. Ya los son negros que me alcanzaron a ver. Ya el corazón triste que en su llama quiso arder, lo mismo que el fuego poco habría de decir que por otra la vendía. La voz de tu destino, soy el fuego en que te abraza, soy el viento en que suspira, soy la mar en que naufraga, soy la mar en que naufraga. Cantar, campanas, cantar, que vuelva la gloria mía.
¿Cómo se ensucian las pantallas?
Bien, buenas tardes.
Good afternoon.
To this event, which will be held in English, but allow me to speak in Spanish, since one of the priorities of the Fundación Ramón Areces is to foster the use of Spanish language in science whenever that is possible. Querida Secretaria General de Investigación, querida Eva,
Madam Secretary of Research, members of the Scientific Council of the Ramón Areces Foundation, dignitaries and the collaborators of Nobel Prize Outreach, and friends all of the Ramón Areces Foundation. I would greet especially the Association of the Scientists outside from Spain that are following us by streaming. My dear friends, I'm the first one to speak, so I have to introduce myself. Of course, my name is Raimundo Pérez Hernández, and I am the Managing Director of the Ramón Areces Foundation, on behalf of whose trust and scientific committee I convey you the heartiest welcome to this event that we have organized with Nobel Prize Outreach. My thanks in the first place, of course, to all the attendees who have taken the trouble to come to the Ramón Areces Foundation. Thank you very much, everybody, for coming. And secondly, I would like to thank the dedication of the team led by Adam Smith and Sandra Van Min for the Nobel Prize outreach, and a very special memory for Laura Stressman, the former director of Nobel Prize outreach, and the key to our alliance. Of course, we think about her and we miss her. It has been a pleasure working with you because of your professionality, and we have become friends. You're so approachable and nice ever since we organized the first one in 2019 in Europe outside Sweden on the future of aging. Some of you will remember. I think it was a landmark that generated a trend of sympathy and understanding in our collaboration with Nobel Prize outreach that I hope and wish will continue in the next coming years. And I'd also like to thank my team that has, of course, prepared this event, working so hard. Thank you very much, Vanessa and Manuel. We're looking forward to the result. The Nobel Prize conversations are becoming a tradition in the Ramón Areces Foundation. Every year at the beginning of the summer, we close the activities at the foundation, trying to present to Spanish society the latest advances in scientific research worldwide and the cutting edge of the schools of thought that is generated in the most advanced circles. And we do this with a fully comprehensive spirit that joins progress and ideas and trends and humanistic thoughts in research, so that finally we can convey a consistent interpretation to the process. In my understanding, the best of the Nobel Prize conversations lies in the originality of the topics that are selected. They're not the usual topics for discussion. They have qualified scientists and scholars, such as the Nobel laureates, in more intimate matters, personal and human issues that can guide you when reaching other spaces. We also called about Inspired by Nature or Imagination at Work. It was an exercise that tried to outline the limits, if they exist, of human imagination and ingenuity. The motto now is the impossible takes longer. When Adam Smith proposed it, I didn't understand. And then it's even worse. He tried to explain it, and I understood even less. But always Adam Smith insisted and drove through because there are many combinations. Adam has his own scientific rigor with a very British sense of humor as well. And above all, he has an extraordinary ability, as you will see, in guiding a debate, moderating, improvising, inventing, and concluding as well. The title today is A Song of Hope, a clear reivindication that, after all, the impossible doesn't exist, and it doesn't fit in the dictionary of those scientists that work in uncharted waters. The success is not found overnight, and as Picasso said, inspiration exists, but you look for it and you see it working. And Professor Mayor Zaragoza, quoting Professor Krebs, the success is thinking about what hadn't been thought before. This is a seminar that we organize with Nobel Prize outreach and places scientists from a more humane and personal point of view. It is a program that is completed with some podcasts. There are some conversations on prior Nobel laureates and specific aspects of the personality and the interview. It's all available at our website. And through the podcast, you can see many things. We're not so different after all. And success is a combination of values like imagination, inspiration, observation, and hard work and perseverance that some, of course, exploit better than others.
Los descubrimientos del profesor George Smoot.
And to my understanding, George Smoot discoveries have been very relevant for modern cosmology. His research helped to confirm the Big Bang theory that has led to a better understanding of the way the universe was created and evolved. On the other hand, the research of Katalin Karikó allowed to generate the first generation of iron vaccines against COVID and face one of the greatest threats against human species. And also the work and research by Mara Dierssen, I couldn't see you, opens new ways to pharmacotherapy in Down syndrome. I think that today more than ever we have to bet on research. It is a challenge in modern societies which are continuously evolving and pose new challenges. As Maria Benedetti said, when we thought we had all the answers, they changed us the questions. So Professor Dierssen, Karikó, and Smoot, thank you very much for not giving up, not quitting, and looking for answers for new questions. And my dear friends, I'd rather finish my words with a message of optimism and hope to consider that after the debate, my general conclusion in that of the Foundation will be a symphony of optimism and faith in humans so that they reach new goals and modulate nature, although it may seem impossible, and always looking forward to it because, as the classical scholar said, it is a risk we must run. I wish you success, and as Professor Boza said the other day, in the French Revolution of 1978, the impossible is what we believe and we create now. Thank you.
Tiene la palabra.
Sarah Brandy has the floor now.
Thank you very much, Ramón. Again, a warm welcome to all of you who are here present here this evening and to all of you joining us online. Nobel Prize laureate George Smoot that are here with us in the room, and Katalin Karikó that will join us on screen. Our dear friend Raimundo, speaker Mara Dierssen, ladies and gentlemen, friends and colleagues, I'm happy to open this Nobel Prize Conversations. My name is Sandra Brandin, and I am the acting CEO for Nobel Prize Outreach. We at Nobel Prize Outreach are delighted to be back in Madrid. This is the third conversation that we organize together with Fundación Ramón Areces. We have dwelled into themes such as how nature can inspire us, how important it is to be imaginative in your work every day, and today on what can happen when you decide to go your own way. For many Nobel Prize laureates, their journey began with the feeling that everyone else was wrong. But they went ahead anyway, believing in themselves, ignoring other people's preconceptions about what is possible. And eventually, the results made history. Walking solo, a solo path can be lonely and tough, and you need confidence, strength, and resilience to keep going. This evening, we'll learn more about the risk of always trusting conventional wisdom and the strategies that can help you survive and thrive if you decide to blaze your own trail. One of our speakers is medicine laureate Katalin Karikó. She was recently interviewed in our podcast Nobel Prize Conversations, and she said that after being given an award, she wanted to thank the people who tried to make her life miserable because they made her work harder and become more resilient. I'm looking forward to hear more from her this evening, and I would also like to encourage you all to listen to this season's podcast if you haven't already done. We have some very interesting and fantastic conversations, so you have a lot to look forward to there. I would like to end by giving a special thanks to Fundación, Ramón, Areces, Raimundo, and our Nobel international partners, 3M, ABB, Capgemini, EQT, H2 Green Steel, and Scania, and to all of you joining us here for this session. So I think it's time for us all to start. So I would like to welcome up my fantastic colleague, Adam Smith.
Thank you very much indeed, Raimundo. Thank you very much, Sandra. And so, yes, hello, everybody. It's so lovely to be back here amongst friends again. I'm Adam Smith. I'm the host of Nobel Prize Conversations, which, as you've heard, is this podcast series where listeners get to meet the new Nobel laureates. And it has been supported so generously and kindly by Raimundo and the Fundación Ramón Areces. So thank you again. Delving into the personalities of the new laureates is an interesting job. Some are very keen to talk about themselves, some not so much. But in these conversations, we explore so many different aspects. In the current series, we go from looking at the shortest possible pulses of light to looking at the role of women in the workplace and the question of why are things as they are. Or from the very strange world of the changing properties of matter when you get to tiny, tiny sizes, to the use of silence and repetition in the writing of the playwright and novelist Jon Fosse, the Norwegian. And so I join in my colleagues' recommendation to listen and just be introduced to all sorts of different personalities. In trying to think of what the topic for this evening should be, I looked across the series of current recordings and thought, what unites all of these different personalities? And it seemed to me that one thing is that they have all swum against the tide of people's preconceptions. They have all, as you heard from Sandra, forged their own path and found themselves in a very, very lonely place. And that does take a special sort of resilience, and so I thought that would be a good topic for tonight. And tonight you get to meet not just one laureate, but as you've heard, two, and the eminent Spanish researcher Mara Dierssen as well. So I'm going to begin by asking George Smoot, 2000 laureate in physics, to join me on stage, please. Do you want to sit here?
I want to sit there.
Well, you can't. You have to sit here. You have to listen to the...
Aw. All right.
Remember,
I'm give you trouble at the beginning.
Remember, I'm the boss this evening. So
the chairs are too low.
Well, get comfortable. Pour yourself some water. As you heard from Raimundo, George was awarded the 2006 Nobel Prize in Physics for listening to the echoes of the Big Bang and detecting in them the seeds of the first galaxies and galactic clusters. Just to introduce yourself, George, you were a precociously brilliant young student. You majored in maths and physics at MIT and very quickly found yourself on the faculty at Berkeley. Did you always know you were going to be a cosmologist? Was it perfectly obvious to you?
No, it wasn't. In fact, I started out studying particle physics that is so microscopically small. And so, but that I did realize, one of the things that I have tried to always teach my students, there is an important problem on the other side. Eventually the snake will swallow its tail. The head will be the giant head of the universe, and the tiny tail of particles, they're going to be connected. And I realized, here's a problem where very few people are even working on it and thinking about it, and very little is known, and here's a chance to be a pioneer in a field that nobody else started in. That's one of the things that I try and teach young scientists now. You know, either you got to be extraordinarily brilliant to work where thousands are trying to find that nugget of gold, or you got to go out into the wilds of the mountains and then find the gold nuggets, right? It's just so much easier if you go where nobody's been going.
But you have to be pretty brave to forge your own path, especially when you're young.
I think so, but I don't remember. I just wanted to, I needed to do it. I wanted to do it. I wanted to understand how the world worked. I wanted to understand, and I wanted to see stuff and understand stuff nobody else had before, and then share it with people. It's not enough to make the discovery. You want to share your discovery and knowledge with other people and encourage them to think about going on and doing, advancing the frontiers of knowledge.
When we talk to Katalin Karikó and when we talk to Mara Dierssen, we're going to be talking about biomedicine. And there you tend to be working on your own or in small groups. When you're talking about cosmology, you're talking about an awful lot of people getting involved. You have to bring a lot of people with you. So the problems of taking your own route are slightly different.
Actually, for me, because I was a pioneer in the field, there weren't a lot of people. I had to develop people. I had to train and so I'll do stuff. First, I'll give you trouble about this thing. This is a non-scientific, but a very typical English form. The impossible takes longer. It grabs your attention because impossible you can't do, right? But it takes longer, which means wait. One of those is wrong, right? And that's the thing we get to. And when I saw this, I was sort of put off because I always be training my students to state things really carefully and precisely and to think them through very clearly. And yet here's a figure of speech. It's meant to stir people up, right? Which is what you did, right? The second talk we're getting ready to do, I had a similar reaction to, and I thought, this is a sign I'm getting old. I should maybe retire. but maybe I can figure a way through it. But one of the things as a scientist that's been my strength compared to when I look and see what other people do is I could actually see a path to get done what I wanted to do. And what I realized was I couldn't do this by myself. I needed to train a new generation of students and postdocs to have the skills to do that. And I set up making a system to do that, whereas I was running some relatively small experiments so that each student or each postdoc had a project they were doing their own, but it was teaching the basics of the science and the understanding, how to build receivers that can see the radiation from the sky, how to run the tests, how to calibrate them, how to do all the data analysis, have them go through that cycle, while at the same time we were working on a big project. Now, obviously, the satellite was a giant project, but you can't just take people off the street and put them into making a satellite. You've got to produce that workforce. Just like you had to produce the workforce, you had to produce the instrumentation. And so I actually saw how you could do that in pieces and build up. And we built it up over, a decade to be doing that kind of stuff. And so I knew it would be hard, but I didn't think it was impossible. I thought, as long as I can get sufficient funding, there are these good science projects we could do along the way. We can get out people's theses. We can get papers and jobs for people. We can eventually do this. We eventually have enough talent to do this really hard, big project. And so it was parallel. You have a substructure of smaller stuff that's going on. It is just like what you see in industry. When Caitlin talks about it, she didn't do that in vacuum. She was working by herself, but there were plenty of people around providing the chemical reagents, stuff. There were other people in other places doing research. She was able to work by herself because the infrastructure already existed.
But it comes down to vision. It comes down to you having the vision to know that this seemingly impossible task is possible, and then building the piecemeal approach to actually making it happen.
And it took me 2 decades.
Exactly.
It's non-trivial effort.
But it's that piece that I think that people, it may seem, it's not, certainly you admit that it's non-trivial, but it may seem sort of within your normal way of working that you take 2 decades to do something. But for most people in the audience, 2 decades is an awfully long time to
It's not normal for anybody. But it's one of the things I teach my students and postdocs, pick a problem that's important, pick a problem that you can make some progress along the way on a stage that makes your career, but pick a problem where you're going to get to some really big answers. That's how you make really major step forwards.
Did you admit your problem to people? So when you were looking for funding, were you asking people to fund the short-term project that was the building block, or were you telling people where you were going?
That was the other thing. I happened to live in a mildly good time. But I was getting funding for short-term projects, and I was getting funding for medium-term projects, and I was getting funding for the large projects. So I had to go to NASA to get funding for the satellite. I went to the Department of Energy to get funding for some of the intermediate and to build new instruments, and I had to go to the National Science Foundation to get money. It's fortunate that during that time, the United States was funding science moderately well, but it wasn't still super easy. But it was possible, to do that. And now you have to have a factory of writing proposals. not a factory of doing science, a factory of writing proposals to keep going. Whereas then, it was a science factory. And if you look and you see what people in biology have done, many of the greatest biology places have had a factory. That is, they've had a whole stuff. If you have graduate students at different levels and postdocs at different levels, the younger guys are getting trained by the next level up. So you have this whole network of people together that are understanding each other, and you're feeding down the knowledge of how to do things. And you have to be the example, and you have to be helping them along the way, but you have to help in a way that they don't always know you helped them. The best situation is when you have someone graduate who think, I could have done it without my thesis advisor, because that's what they have to do now.
Right. Just before we bring in Katalin Karikó, I'd like to ask you what it was like to get to the end of this path. 2 decades, and then you saw the data from the COBE satellite, and you were able to analyze it and see these little seeds of galaxies that weren't necessarily going to be there. What was it like getting the data?
It was amazing in different ways, because you're guarding yourself in the jump to the conclusion you found something. You have to go through checking it all the time to make sure there's not a mistake, that something was wrong with your equipment, or something wrong with the way you did the observations, or something wrong with the way you did the analysis. You have to check all those things really carefully, because you really wanted to make a discovery. And so if you see some bump in your data, you think, oh, great. You've got to be careful and hold yourself back. Then you finally can do it, and then you can do that. And I remember one particular night where I was working hard, and I still wanted somebody to check me. So I had a graduate student that I was saying, don't go home tonight until you run this run, because he kept going off and doing side stuff. And finally, it's 11 o'clock at night, and he runs it. I mean, I've been on his case for like 5 hours, right? And he finally runs it. And his results look pretty much like my results. And he had written his code and done everything separately. And I think, there's a cross-check. I'm having to walk home. I'm sort of gliding down the hill. You take these long steps, and you're just like skating down the hill. And I go, and I remember it's got to be past midnight, because the traffic light is flash. There's one traffic light there. It's flashing. It means it's past midnight. That I remember. And then I realized, uh-oh. Now we got to get this together and publish it. And so a whole new set of work. But it was still exciting. But it really wasn't until we made the scientific announcements followed by a press conference. And the public response was so incredible. It's like you're a doctor in an emergency room, and you're helping somebody who's come in from a mono crash, and you're really working on them like crazy. And you look up, and it's your son. It's like, oh, wait, this is real.
And then life changed.
And then life changed. And then I was actually famous. People were asking me today about what it's like to be famous. I was actually more famous at that time. I couldn't walk down the street without people recognizing me. But then, later it sort of came back again when I got the Nobel Prize.
We'll talk about all that in a little while. Let's bring Katalin Karikó into the conversation, please. Katalin, are you there? Hope she's going to pop up on that screen.
She's across the ocean.
Oh,
yes. She's popping on that screen.
Katalin, there we are. Hello.
Hi.
How very kind of you to join us. And So
I'm sorry that I cannot be physically there. I was just there in Europe a week ago, and now I have a grandmother duty with 2 little children, and so that's why I am here back in the United States, and I couldn't be in Madrid, but hello, good evening to everybody there.
It's wonderful to have you with us. And you're talking to us from, is this home in Pennsylvania?
Yes, yes, it is my home.
You seem to have a lovely wall of awards behind you.
Yes, yes, I have actually four units. My husband made this special to keep all of these awards in display. But recently I gave many of them to my alma mater so that they can display and the people can look at there, and maybe the young one get inspired by that.
I don't, and maybe they dry up after the award of the Nobel Prize. I don't know, George can tell us, but some people say that once they get the Nobel Prize, everybody else stops giving them an award. I don't know if that's true.
I didn't get so many more awards, but I get a lot of presents. And your cabinet, that wall is not enough.
More presents to come. Anyway, Katalin, so as I'm sure the audience already know, your belief in the power of mRNA to be a therapeutic eventually was instrumental in the development of the mRNA vaccines, which were used against COVID-19, and indeed probably most of the people in the audience have been injected with the Pfizer-BioNTech vaccine that you were so important in developing. But what they may not know is that your belief in mRNA caused you a lot of trouble along the way, that you thought it was going to be a successful therapeutic, but a lot of people disagreed with you, and it cost you a lot. Would you like to talk about that a little bit?
Yes, indeed. I started to work with RNA in Hungary as a graduate student, and as an undergraduate student, actually, I worked with lipids and delivered DNA to cells. So early on, I started to work on this field, but you know, the RNA at that time was a short RNA, not the mRNA. And anyway, I lost my position there and ended up in the United States, and then worked for 3 years at Temple University, again working with RNA. There we work also long RNA, double-stranded RNA. We treated HIV patients with double-stranded RNA at that time in 1986. That was the problem. And from 89, I started to work with messenger RNA at the University of Pennsylvania. I worked there for 24 years, 24 years. Time flies. So it was 24 years, and yes, again, it was not very successful because on the 40th birthday, I was demoted from my faculty position, and when I was 58 years old, it was like 10 years ago about, I was permanently terminated, and my stuff was thrown out. And I would suggest every time, you know, when I say thank you to those people who try to make my life miserable, I also, you know, say that the termination or kick, when you lose your job, is somebody else's decision. And I always focused on what next. And that's what, when I was 58 years old, and I was so proud that I had 2 job offers, one from Moderna and one from BioNTech. Of course, 10 years ago, nobody knew these companies, not even a website, but I decided to go to Germany. So it is important to always focus on what next, what you can choose, because other people already decided that you are useless, and that's helped me, you know, to maintain. And as you mentioned, I say thank you. So people who try to make my life difficult, but I never say thank you to any of the students, my postdocs, because I never had one. I did all of the experiment with myself.
It's extraordinary to have such a positive outlook. I mean, I don't think most of us are able to have that strength not to be angry with everybody around one for making life difficult or not. Where does that inner strength come from, do you think?
At age 16 in high school, we corresponded with János Seje, a Canadian-Hungarian scientist who coined the word stress. And he wrote a book, and it was translated in Hungarian, because we couldn't speak English, we learned Russian in Hungary at that time, and behind the Iron Curtain. And then we read this book, and it helped us to understand that stress can kill us, depending on how we handle. And we have to handle the stress properly and convert the negative stress to positive one, because we need the positive stress, the excitement, the anticipation. And so it is not coming easy, you have to practice it. So when you are angry, you feel immediately relaxed if you think about revenge. But he said never do that, because it hits you back and it escalates. And he gave a lot of advice that what not to do and how to handle things. So when you are very angry with somebody, you have to find a way how you can feel gratitude towards the same person you were just ready to step in their back. So that's takes practice, but you can do it. And then also when you feel gratitude, it will get back to you and it escalates, and you can calm down completely. And so that's what I used usually, that when I had a difficult time. And what the Stoics said, that you have to always focus on what you can change. And of course, when I could see that other people advance, and I don't, and I feel that I work so hard, if I wouldn't notice that already, I would take away my attention what I can do, because I cannot change that somebody else is the PI favorite, or somebody's doing well despite lousy work. I cannot change that. I can change what is in front of me, my work, and then I have to focus on that. And that's what helped me not to discourage when, I was demoted, I was kicked out, terminated. Even one point I was subject of deportation, and my supervisor at Temple University called up Johns Hopkins, and they withdrew the position because, he was a professor and he could convince them that I am, a fugitive, although we get a lot of publication in 3 years when I was at Temple. But, that he was a professor and he told me I was nobody. But I didn't felt sorry for myself. I immediately had to think what I can do when I have no recommendation letter, and thought about all of those people who didn't like my supervisor and asked for help to get a job. So that's how it happened.
It's a quite extraordinary story, Katalin. I mean, it's just to reflect on the strength of character you've shown. And I suppose some people in your position now, that you are world famous, you were proved correct, might gloat a little bit and be rather pleased that somehow it all turned out well. But I imagine, listening to you, that you don't think that either. You just carry on doing your own thing, and it doesn't really affect you.
Yes, indeed. And I met some of those people, that who treated me kind of harshly, but I never complained to them, and I never tell them, you see, you were wrong. Because I have to say that when later, even Professor Suhadolnik, who wanted to deport me and who cut me off the Johns Hopkins job, when a couple of years later I went back to give a lecture at Temple University, I thanks, because I have seen him there, I thanks to him that he invited me to the United States, and I was thankful. A lot of things I learned from him. And he was very proud of me. He hugged me. And I was sure that he did not remember the rest of the story, and why should I? And that's what I tell everybody, that do not hold grudge against anybody, because it poisons only you, and the other person will not even remember. And then So that's it. And it was the same, and all the chairmen, that thought that he might be responsible for terminating me in Hungary. And I visited him in an elderly home. He was 95 years old, and he was worried about that he was responsible. I have to say that I did not even remember how I ended up when I was a super student. Well, in Hungary, I get the highest award when I was student, and I get the academic scholarship, and which is very difficult, like 2 biologists per year could get. And how did I ended up now that without a job? Of course, in between I get a child, and then I lost my permanent position and temporary position. It was easier to terminate me, but I didn't know really who was responsible. That I told him. It definitely he wouldn't be do that, I really honestly did not remember how I ended up on the street, but it was not important. And that old man, that who could relax and could he died already, but I don't need to dwell into things.
Oh.
We don't need that.
Thank you. That's inspirational. So, George.
the Katalin has a... Katalin has a book out, and maybe she has more in the book about what her life was like and what was going on. I was trying to find a copy of it because our friends recommended it. Nora found a copy in the Budapest airport, but it was in Hungarian, and so we didn't get it because I can't read Hungarian. But
yes, I can tell you that it is out in French, Italian. It's coming out actually in Spanish in September 4, and German in next month, and it is out in Japanese, Chinese, Korean, and 13 different languages. I give advice that everybody could live a much happier life. Everything, environment would be the same, but thinking differently would make people much happier. And that's I give advice what I learned from Shaya and my experience during these 40-something years I was in scientist. So,
does Katalin's experience ring true with you, George? Have you experienced the same things at all?
It's difficult for me to say that because I always did things the hard way. And so I didn't pay so much attention to what other people were doing as wanting to do what I thought were there as important things to do. And fortunately, a lot of the times I was in Berkeley in the Vegetable Lawrence Berkeley Lab, where they had, from Lawrence and Oppenheimer and the other people that were there before, they had the attitude, take smart young people and give them some money, and if they do something good, give them more money. And so as long as I was making progress doing good stuff, they kind of supported me, but I didn't care so much. I wanted to see what the world was like.
Again and again, this idea of not paying attention to other people seems to be so crucial. I mean, I don't mean negatively. I mean that if people are telling you don't go down a route, or people are advising you to take some way, if you know what you're interested in and where your curiosity is driving you, that seems to be the key. Just allow that to...
I mean, I had heroes, right? Marie Curie was a hero, and Einstein and Fermi. Those people that were the previous couple of generations, they were heroes. And there were even some that were sort of a little bit more senior people when I was around. But I didn't listen to them. I learned from their example and went on to do my route, right?
Do you have heroes, Katalin?
Yeah, it's of course, but mine was mostly my parents who, I learned so much, that hard work is part of life. And of course, my teachers, which I dedicated the book, all of those who taught me how to read and write, and those who showed me those chemical experiments, who took me to different road trip, and we learned from nature. And I also, even my graduate student classmate, like Janos Ludwig, we in the communist system we have to harvest grapes in the fall, and then when I met him, in '77 on the field, he asked me that, what do you think about the Voyager? And I looked at him like, I don't know what he's talking about. And he told me, if you want to be a scientist, you have to follow what fellow scientists are doing. And then I went back, read about Voyager 1, Voyager 2, what it is doing, where it is. And from that on, even today, I am following what is. And Edward Stone, actually, who was the PI, I get an award with him 2 years ago. And it is, the important thing is that we follow fellow scientists' work, and we proud of them, and even some level we understand what they are discovering and what they are doing. And so I learned a lot, not just from the teachers, but even fellow scientists who were, at my age, or fellow students. I was listening, and I realized that they were right. And so mostly my idols is the teachers, because they sacrifice so much, and to provide experiments and help us to understand things, and the way that it is enjoyable, so that not like, they try to, push us to memorize things, but more like, how nature, how interesting is this and that, and that's what, the art, what they really they mastered. They were teachers who taught us chemistry, mathematics, and then show it in interesting ways.
Again, it's so difficult to generalize across personalities, but just before I bring Mara into the conversation, one thing that many laureates seem to me to have in common is this ability to focus utterly on a question and yet maintain this broad interest you're talking about in so many different things. George, in your case, earlier at lunch today, you were coming up with a theory on something, and I said, you have many theories, and you said, I have a theory on everything. And it's true, you're very interested in every aspect of life. You're always thinking about all sorts of different things, as well as sticking to cosmology.
One of the things that I was taught by my heroes, her teachers, and so forth, one of the things I was taught by my science teachers, the people who taught me how to do science, was how to think scientifically and how to ask questions that you don't necessarily think fall in science, but may have a simple scientific explanation and may have, easy to understand reasoning results. So I tend to make theories of most everything because I want to see whether it fits to a theory or whether it's just, so chaotic. Right?
Lovely. Okay, now, Mara, please welcome Mara Dierssen from the Center for Genetic Regulation in Barcelona. Hi. Thank you very much indeed. Yes. So Mara, as you've heard, is an expert in Down syndrome and runs the Cellular and Systems Biology group at the CRC in Barcelona. And maybe I should just ask you to start by reacting to what you've heard from George and Katalin so far.
Well, in fact, I also think that we tend to focus, scientists don't have projects. We have obsessions, right? So we are getting obsessed by one question, and you pursue it to the very end, So this is something that I also feel. I started many years ago in neuroscience and then investigating the basis of neuropathology, basis of Down syndrome. And when I started, somebody told me, why are you studying Down syndrome? this cannot be cured, right? So why? And, you know, I think that as scientists, we're privileged because we can decide what we would like to focus on. We can decide which is our scientific question, and we can pursue this question, and we can really forget about what others think about what you're studying, right? So this is something that I feel that is making us really privileged people.
But you do need to convince somebody to give you the money to pursue your obsession.
Well, let me tell you, this happens nowadays, but look at Ramón y Cajal. He, with this tiny microscope, with almost no funding, he was able, just by thinking and observing for years and years, to devise one of the most influential theories in neuroscience, right? The neuronal theory. So he was able to really define even the direction of the information flow in the brain. So it's amazing, with almost no means. So sometimes, you know, I think, do we really need all this very sophisticated equipment to really find out, or all this big data? That's fantastic, yeah, I kind of agree. But then you need to think about what you have obtained, right? All this data, all this information. And what I think is that having all these big equipments, big funding, etc., does not necessarily bring you to the correct answer, or at least does not really drive you into the best way or the best question.
That's so interesting because, I mean, ideally, everybody is like Katalin and is happy to, not happy perhaps, but content to pursue their own path and not worry about the reward systems around them. But practically everybody is not like that and wants to rise and to get the kudos of getting a better job. And to do that, you have to build the system around you. Maybe science needs, globally, a slightly different system whereby it is possible just to be an isolated mind pursuing something and be accepted and rewarded for that. I don't know. What do you think?
Well, I mean, the system is the system, and if I may, the system is now not very friendly because it's driven by this business model, no, in which you have to publish or you will perish, and in fact, it has been changing, no? Now you have to publish in high impact factor journals or perish, and now even more, publish many times in high impact factor journals or perish. And of course, you also have to think about your group, the people that works with you, etc. But, you know, I think that this is a little bit perverse because we have a kind of a conflict of interest with ourselves every time we publish, right? So when I started, you had to write with the type machine, right? With the writing machine, your paper, 4 carbon copies, you know. You send it by postmail to the editor, and 3 months later, the editor receives the paper, and then he sends it out to the reviewers, and then maybe 6 to 8 months later, you receive the answer, right? Now you press a button, and immediately you get the email back. There we are. And we have learned to live in this kind of fast science model, right? That doesn't allow you really to think. And, you know, it happens when you ask for money. Every time you ask for money, they ask you feasibility and innovation. I mean, I cannot innovate every 3 years. Come on, I need time to really think about the questions. So the whole thing is making science evolve in a way that it's, I mean, I have to say it's less fun somehow, because what is really fun is to be driven by curiosity. And now, if you want to do a very disruptive project, then you have to do it in your free time, like we call it the Friday night projects, right? But those are the funny ones, right? And in a way, you will find all these interesting things.
I like the fact that in Spain you call it a Friday night project. There was a Nobel laureate called Oliver Smithies who used to call them Saturday afternoon experiments, where you just go drop, drop. It made different cultures have different parts of the week that are.
We love Friday nights, you know.
But given the title, especially, The Impossible Takes Longer, let's talk about fast and slow science. George and Katalin, I'd love to hear your view on that. Who wants to go first? George, do you want to?
Which part do you want to hear my view on?
About fast and slow science, the fact that the current environment is pushing people towards a much faster turnaround, and therefore an expectation of coming up with ideas all the time, and not the time you're not having the time to reflect.
So it's actually a complex interaction of things that are going on here. And when you look on the surface, it's that way. The fact is, everything is going faster in modern society. You know, we're developing more technologies more quickly, right? It's just because if you learn more, you know more, you have more things to work with, more pieces to put together. You know, to make a machine that will microwave popcorn, right? You need a door, you need you need these pieces. All those pieces are lying around. All you got to do is put them together, and you can do it. It'd be easy for you to invent the microwave now. It would be 100 years ago to make a cell phone would have been really hard. I mean, it's really hard now. I took a cell phone apart recently. And it's really complicated in there. And the fact is, science is moving at an increasing rate. So is technology. So is society. Why do we support science? Well, the government supports science because it's been part of the reason we've been having world economic growth, right? And so the government sort of makes it a policy that putting out 2-3% of the GDP into science research and technology development, but is going to help grow the economy and pay the government back in a big way. We're about to reach a new things, and that's happening faster. We're about to reach a new phase. There's a big change coming because of artificial intelligence. And the societies in which scientists and artificial intelligence can work together, along with the technologies and engineers, are going to grow faster than economies that don't. And so which economies are there going to be? Well, China is making a big push to do this, but they want to have relativity control. So they're going to have a forced march at 5% per year, right? What's Europe going to do? Well, Europe's been doing 2, 3, sometimes 4% a year, but that's, I mean, China leaves you too far behind. You just look 20 years out, and it's really, so the fact is, the EU is already right now thinking, what are we going to do to remain a big player in the world when we have North America on one side and we have Asia on the other side, China and India both pushing up? How are we going to do that? And so my feeling is it's not nice now. It's going to be a forced march in the future, right?
It's going to get a lot worse. Oh dear. Okay. Katalin.
I'd rather be more positive, but
well, no, but bringing it back from the continental scale to the personal scale,
right?
On fast and slow science, what would you say?
Yeah, definitely I did the slow one. You know, I never published 100 papers in my life, but all of them is reproducible. I did myself with my own hands, so it can be reproduced. So the problem is, you know, that in these days the papers are like 40 pages. At the beginning, when I started, it was 3-4 pages, and I love to read old papers from the 60s, 70s, and what you could see, little data, and then a lot of thinking. You will feel the author, that what is thinking about this little data, and I just love that. And what I realized in Hungary, I learned everything, the frogs, the corn, everything. We had to learn everything, so we were like a polyhistors. Eh? And then I came to the United States. I realized that a biologist wouldn't even know anything about the corn. When he said it was a long corn, probably 6 cobs in it, I said, have you ever been in a cornfield? There is not more than 1 or 2. He saw that it was so tall, and so the knowledge is there is no polyhistors, you know. And then how I felt, and in more and more people know from less and less. And finally, here, you know, how I feel is they know everything from nothing. and not, you know, not looking up. So what I, and very much agree with Mara, is that you would go just read papers. You don't need equipment, nothing. Just read what is already known on different diseases, even for, you know, Down syndrome, and realizing that they had certain type of diseases and what is the genes, extra chromosomes, and understanding how it contributes to stroke and other things which these patients were suffering. And then you just have to read those things. You don't have to do a clinical trial or something. You just read it, and then you would understand, create a hypothesis, and then try to poke hole on it, you know, and then have a better understanding. So that's what I did. You know, I was reading on a field for 40 years, and right now I am focusing on to initiate a clinical trial because I think I understand a disease which others not understand. And because it was, everything was there, but it is, everything is so enigmatic, and everybody is focusing on one little thing here, what little thing there, and nobody was reading cross to understand that, okay, that's it. So that's what I feel about, you know, very sophisticated science is going on. Of course, you know, it's good to all of these genes. And you remember in 1990 started the Human Genome Project, and we thought that when it ended, you know, 13 years later, we thought that we will get all of the answers. Of course, we did not get, and then we didn't even have a tools how to interfere. So we have to, we could be more efficient. Just go back to read the literature, what people already discovered. And I can see people rediscovering recently, you know, that was this, like in our field, the circular RNA. They discovered that circular RNA can be used. I mean, I presented the last talk that in 1994, I already had a rejected grant on circular RNA. So people think it is novel. I already had rejected papers or rejected grants. So nothing novel. You just have to look back, and you realize that people already discovered so many things. But, you know, people do not like to read. I remember how happy I was reading Nature Science A to Z when, you know, I came to the United States, and I could have my own journal. It was physical journal at that time, because in Hungary that we get one in the whole institute, and then you were waited late night that somebody will put it down so you can run in there and grab it, and so then you can read what's going on the world. And we were, you know, we sent out requests for preprints actually, and I'm very grateful. Thank you everybody who from Spain and other countries sent us you know, their publication, because this is how we could keep up, you know, with things. And you know, although not in the question here, but I was behind the Iron Curtain, and every sanction was limited us. And every time there is a sanction against a country, I am always thinking about the scientists, because, you know, how they suffer there, you know, because the science is universal, you know, just like the sports. Who cares that which country coming, that who jumped the highest or run the fastest? And, you know, we just amaze people, yeah. And then the science is the same way. Is you know, which scientist discovering which country? I don't care about the nationality, you know. And so it is, you know, I feel all of the scientists who, you know, suffering right now because the sanction. Because I remember how did we suffered, and we couldn't go anywhere, we couldn't get materials and so on. But I know that it was not the question. It was about, you know, that how we.
That's okay. Thank you very much indeed, Katalin. Thank you. I want to turn. I want to turn to the audience for questions and comments in a minute, but just before we do that, one of the things that is necessary if the world is going to support people to follow their scientific curiosity is public support. And all three of you are involved in outreach to the public in different ways. Mara, if I start with you, it's a rather unusual way that you reach the public through a rock band. Would you like to tell us about it?
Well, not only, but yeah, I mean, you know, we have this music project, let me call it like this, sound more serious, right? In which we play rock.
That's a euphemism, a music project for rock.
Yeah, and what we do is we collaborate. So, for example, we would like to make visible the diseases, right? So we collaborate with patient associations to give them the floor to really tell the people what is the disease. For example, in the case of people with Down syndrome, we were launching a couple of CDs with letters of songs written by people with Down syndrome or other intellectual disabilities. And in fact, we did in Abbey Road in London.
Yeah. Good studio, yep.
Yeah. And the other thing that we also do is we do something that we call unconcerts, because there we speak about neuroscience, but together with some rock. And last time we did this for high school students. So I normally kind of tease the people a little bit with questions and so on. And my son was telling me, my son is playing in my band, he was telling me, Mom, don't do this today, they are high school guys, so they will not laugh at your things, and so. And I say, well, I will do whatever I want, but yeah, thank you for your advice. And you know what? It was amazing. I mean, and we got such interesting questions for these very young people there. And then on the other hand, they were dancing. It was like an auditorium like this. They were dancing around, doing something that we call conga, no? And so it was really fun. And after that, many of them came and say, hey, how can I be a scientist? What should I study to get a scientist, no? To be a scientist. And I could not agree more with Katalin before when she said, you know, that the way we wrote papers, or people wrote papers years ago, was so different. So my father was a neurosurgeon. And one of the things that made me get into neuroscience was reading one of his papers. In the abstract, he was saying they were studying in patients, surgical patients, so they were putting some electrodes on the brain, etc., right? So to see which regions were doing what. And they were studying visual perception. So his questions were as simple as, how many neurons do I need to perceive one visual information? Where are they? How are they synchronized? How does this work? And I thought, wow, that's amazing, right? If I get to really understand how it works. And now we are, with all these new techniques and so on, because new techniques, what they help you to do is to really make the questions in a different way, to see the problem from a different perspective, right? So now we can play with memories, with single memories. So we can tag the neurons that they get activated when you learn. We can reactivate those and reactivate a memory. And we have learned, for example, that in Alzheimer's disease mouse models, you have the memory there. The only problem is that you cannot retrieve it. Instead, in intellectual disability, the memories are not correctly formed. So it's very different, right? And all these things help us to really understand. And as she was saying again, no, when we had the Human Genome Project, of course, for the Down syndrome community, also the chromosome 21 was the first to be sequenced. I was very privileged to be in the lab that did part of this sequencing. We thought, we have all the answers. Of course, this was not true. But the most interesting thing is that the part that has now revealed to be more important, that is all these non-protein coding regions, because we didn't understand it, we call it noise. Because everything we don't understand, we call it noise, you know? This is junk DNA, this is noise, this is whatever. So, you know, it's an interesting way.
Very much so, and having the right question is again and again and again so important. Okay, thank you. Outreach, George, you reach out partly by being a TV personality. I guess the audience may not know it, but back in 2009, George bravely took part in a US game show called Are You Smarter Than a Fifth Grader? And brave because almost everybody turns out not to be, but George was the first man ever to actually win that game show. So, and you've been on The Big Bang Theory?
I was on The Big Bang Theory, and I do a lot of, you reach a huge audience that way, but I've done some other things that are outreach that way. One of the things that I realized after going to schools and talking to students to try and encourage them was I would go and spend an hour with them. Their teacher was with them all day, every day. So I started a program to educate and provide materials for teachers so that science teachers would have more lessons and do more stuff. And we ended up eventually, you know, hiring a few teachers a week over the summer so that they could do, and we could run these teacher workshops and academies to teach science teachers how to teach science. And then eventually we created a series of teachers academies spaced around the world, one in California, one in Europe, one in Korea, and so forth. So the goal was to have them 8 hours apart so you could give teacher support. You know, there'd be online teacher support available around the clock and even do that kind of stuff. And we trained the very first high school science teacher that Kenya ever had, and we supported her to train another set of teachers, you know, a class of 20 teachers, so that Kenya went from having 0 high school science teachers to having 21 or something like that. I don't know how many of them survived through the whole sequence, but there's a whole series of things you can do. But then I learned about that, and with Pierre Benetoué, well, one of the things I did, I convinced the French science teaching, whatever the education industry, to make cosmology part of the curriculum, is because they control the lower division classes. The curricula are controlled quite severely. Teachers don't quite have enough. And in return, that's when we started Teacher Academy to provide them teaching material because the teachers weren't qualified for it. And
it's so crazy that cosmology wouldn't be part of it, because in a way it's the thing that people are naturally
interested in. It puts it all together, yes, and that's why I managed to convince them. And then Pierre Benetoué and I did that, and we knew that LIGO was coming along and was we hope to discover gravity waves according to our calculations. So we started an online course, the MOOC, these massive online courses. And that course turns out to be half of all my teacher-student contact hours in the world, because the first year when we advertised it, we first did it on the French one, which is more limited. Then we did it on the French and the English one out of London. And Pierre called me up and he goes, "Oh my God, we got 40,000 students signed up. How are we going to handle this?" And I said, "We need more. Let's advertise it." And we ended up with 70,000 students in this course that finished it. And luckily, gravity waves were discovered, which made it a little more excitement.
Well, but it's things that capture people's imagination. Gravity waves are something that is so attractive to think about.
No, it was about it was a course on gravity. The gravity waves, but we did a lot of. We actually studied something about teaching. You understand that standing in front of people and lecturing is actually one of the worst possible ways to get into material, right? There's a reverse. You want a reverse classroom. You want so we had videoed, demonstrations. We had videoed questions, and we had quizzes, online quizzes that we could get immediate answers to. We did all these things that were the way you're supposed to teach more effectively. The most effective way you can teach people is have them do it.
And
the second most effective way is to make them get engaged, right? They have to get engaged and so that's why I say it really was a huge impact. And for a long time, we had the most students that had, except for, of course, on how to be a refugee in England. That had slightly more students than we did. And then one of my colleagues in Hong Kong surpassed us after teaching for a few years, teaching the chemistry of cooking. And he was teaching people how to cook and understanding what's going on in the cooking and so forth. And by doing repeated runs of the course, it's got more total.
It's a good way of getting the chemistry across to people, very much so. But you didn't take the bait on the fifth grader thing. And since you mentioned quizzes, I'm going to ask you directly: how scary was it to go up against a bunch of fifth graders?
The fifth graders are young, but they're really smart. They're not that big, but they've learned a lot. You know, the fifth grade is, you've been to school for 5 years. You've actually learned.
Yeah. And you're still enthusiastic at that stage.
And they're very enthusiastic. And they pick the smartest, cutest kids to be on there with me. And so, I mean, you're there with 5 scene stealers, and they're all dominating the show. And you know, it's a little scary to have the pressure on you like that. But you know,
you survived.
Somehow I survived. Right?
Sorry, Katalin, it's difficult for you online, but when it comes to outreach.
Yeah, I am still here, and I am listening with great excitement what George is saying, because really who does things can teach the most. And of course, you know, for the fifth grader it was easier, but you know, even at the university, what I could feel is that why in the United States is so going so well, many things, because at the university, who is teaching, who is doing things in the front and the best, and somehow in Europe more like there are research institutes, and the front research is going there, and somehow the university is you know, not at the front of the research. What they are doing is you know, is difficult to teach, because they sometimes, like, you know, I also had somebody's teaching what they just learned 10 years ago. So it is the best thing when somebody who is doing things, that's what teaching. Of course, you know, in fifth grader it is easier, but you know, when you go to the university is more difficult. I mean, during different award ceremony, I was participating, you know, outreaching to students. And yes, when 300 high school students is sitting in an auditorium, and you are at the stage, do you think that anybody is paying attention? Everybody had a telephone. Everybody was sending a message to the guy who is sitting next to him. You know, everybody was busy with those things. You know, those high school students are difficult to get attention, and you know, and they couldn't name a single Canadian scientist. I was very disappointed that, you know, how they could name all of these famous people who did nothing, and then scientists, and even if you think about people who are taking in the morning a medicine, saving their life, why they are not asking who come up with this, saving my life, you know, and who is responsible for it? It is the journalist, we, the scientists, that we are not talking to them and telling, so that why the scientists won't have more respect, and why the work we are doing, why it is not more known for the public. And I during those you know, last 3 years, when I had to come out from the lab and give interviews, and I was at the beginning, you know, seeing a microphone, I was just numb. I couldn't say anything. And then I realized that we have to educate the public. Because the knowledge, what we collected, and the distance, what they learn in school, you know, the average person, the gap is so huge, and we have to help them to understand things better. We have to use a simpler language. We have to have the, you know, the reporters to simplify language to communicate scientific achievements for the public. I don't know if people can think that, oh, the Voyager is out of our solar system and somewhere out, you know, running 60,000 kilometers per hour. Somehow people can think, okay, and then some scientists can turn the camera back and we take a picture. Somehow they can imagine, you know, or they, and it is similar what we have in molecular biology, and so somehow we have to communicate them that somehow it is possible, and then they would understand better and respect better, and they won't be scared if there is something like a vaccine is on the scene, and scared that, oh, scientists want to kill us or something. I don't know. These theories are created. So,
Thank you.
and when I get an award, I also felt that, you know, science and scientists is on the spotlight, and finally, it is an important thing. Yeah.
Thank you. Mara, please.
No, in fact, I think that part of the problem has been that for many years, scientists were not thinking that it was important to communicate science to the general public. Not even that. I mean, I started many years ago with something that was called the Brain Awareness Week. So many neuroscientists go out to the streets and so on and talk about science with the public. But at that time, what I was told is, why are you wasting your time doing this instead of doing research, right? So it was not even valued by ourselves, by our community. And I think this has been a problem during many years. The other problem is that in many cases, people in science do not know how to talk to non-scientists. So they get very technical, and then people lose interest, right? So it's also something that you need to learn.
It's a difficult balance, though, because you don't want to get technical, but at the same time, you just don't want to gloss over everything. Because one of the things I feel about science reporting generally is that it just tells a lovely sort of simple story. It's always like, this is good, this is what we've discovered. None of the, you know, it's not like politics, it's not fun, and there's kind of, you know, this sort of stuff. And the truth of science is that it's more complicated than the story.
Absolutely.
And people would actually like the complication, I think.
Exactly, but you have to explain it in a way that if you use words that they get lost, then they lose it. They lose track, right? You can explain the same, but explaining what you mean.
Yeah.
And this also happens across fields, right? If I talk to somebody in physics or whatever, I have to explain things in a way that they can understand what I mean. If I start speaking about an engram, they will say, what? But if I explain what I mean, then they can follow the story.
Good. Okay, well, let's talk to our public. Here they are. Some of them are no doubt very sophisticated researchers, but please, who would like to make a comment or ask a question? Don't be shy, and you can speak in Spanish or English, whichever you like. We have microphones. So, yes, please.
Thank you very much. I'm a teacher. I'm one of those fifth grader teachers. So, would you have any suggestions for us, for the children, any way we could improve our work with them? I've heard you've said to get them involved, to not make them learn everything by heart, but get them to do it by experiencing themselves. So would you have any suggestions for us? Thank you very much.
Thank you very much for the question. Who would like to jump in with a suggestion? Whoever speaks first.
Okay, so in fact, one of the problems that we have with the way we educate at school is that somehow we are, if I may, and it's not my sentence, but it's Ken Robinson's sentence, education kills creativity somehow, right? You are trying to explain them how to do things in the correct way. And then the other problem is that we're trying to put the knowledge there, like, you know, and the knowledge increases exponentially. But then it's a very superficial knowledge somehow, right? So there is a whole, let's say, field that is called neuroeducation. So what they are trying to do is they are trying to bring our knowledge about how the brain works. And some things are very simple. So for example, we know that during adolescence, there is a shift in the circadian rhythm, right? So if you try to make an adolescent guy or girl study something at 8 a.m., they will understand nothing. So probably we have to shift a little bit, and they could start at, let's say, 10, and they stay longer if you want. And then the brain has a attention span that is relatively short. You cannot speak for 4 hours in a row, right? Because they will not pay attention. So there are many tricks, many things that are out there that we know from science that can be applied.
I do know Nobel laureates who can speak for 4 hours in a row, but that's a different thing.
I'll try and keep this a little short. But it depends on how revolutionary you want to be with your teaching. And as I told you, if you actually study education in terms of how you train people best, it's getting their hands on it. So I did an experiment with a science high school where I went to them and gave them a talk, and they got all excited. And I said, there is coming soon a transit of Mercury across, either Mercury or Venus, I forgot which, across the face of the moon. Find a partner high school in Australia, and both of you measure when the transit occurs and how long it takes apart, and tell us how far it is to the sun and how big the sun is. Okay? It's a simple problem, but not a simple problem. These students were extraordinarily motivated. They got their telescopes out, they took pictures, they did a better job than my college students did when I gave them the same problem. And they just put so much time and energy in it, and they did this kind of stuff. And then when I came back to review it, they gave me a talk, and they even had a guy explaining why they didn't get the right answer. You know? And they weren't that far off. It was in the error. They didn't have the concept of error bars yet and so forth. But the fact is, there are many projects you can do in school in which the students get to do an actual experiment, and they will get so engaged, and so when you put your hands on stuff, it becomes part of your life. It becomes part of what you're learning. So they found that, for example, the George Washington Hospital found the best way to teach people to deliver babies was to have a whole complete mock-up hospital, obstetrician wing, and have the trainee nurses be in there giving birth to plastic babies and so forth. Doing the real thing it focuses your mind really more and makes you study and understand stuff. And so you can't do that for everything, but just to try and package in the same set of knowledge, you got to learn, plane geometry and 3D geometry, all the stuff that in school they're trying to force you to teach on the students. The students are not so motivated and so focused to study hard and really integrate that. But when they actually have to do a real problem, they'll learn that stuff really well.
It's about ownership. It's about it being your problem. I mean, you three on stage. Right.
It's exactly.
You all have
ownership and engagement and wanting to do a good job. And people want to make things or do things. They want to show they did a good job. They want to show you something good.
Thank you very much indeed. Thank you for the question. Please.
I would have to say very simple experiments, which we were doing. Actually, we had we did crystals. So we had a saturated salt solution, and we hanged in a thread, and then we were waiting for the crystal to form, and then we were just so happy that we had our own crystal. I remember I went home, I tried to repeat this experiment. I put all of the salt in the pot and heat it up and cool it down, and all just go out to the forest or something in a tree and look at there, and now it is green, and then in the fall you see yellow. What happened? the green became yellow, or the yellow was always there, or where the red is coming from. So very, very simple question, or now the stork is coming, going, and how do they find come back here? You know, today you can say the kids that, oh, probably the stork has some kind of GPS and could find the way back, but anything, you know, which is around them, that's how in a fifth grader can see things and then think about and understand the nature around them. That's how I would have them.
Thank you. Thank you very much indeed. Another question, please.
Hello, everyone. You have talked about how the way we write papers has changed from the classic way to the modern way, and you have said that it's going to get harder still going into the future. So as a young person, myself a physics student that wants to go into academia, do you have any advice to the new generation of, you know, do not be scared of the process, do not be scared of failing, just any advice to the newer generations?
I guess, George, that lands squarely with you, physics.
Oh, God. First of all, really want to do that? Do you really want to go in academia and be a teacher and a researcher? Right? And do you have the skills? Right? How's your math? How's your personal skills? How's your writing? You know, surprisingly, to be a scientist, you've got to be able to write and speak. You can't be a teacher if you can't stand up and explain your ideas to people, and you can't get research grants if you can't get up and present a really coherent proposal of what you're going to do. Even if you don't know what the outcome is going to be, you still have to say, this is what we're going to do and test. And so it requires skill to be a scientist professor. It requires certain skills to be like a poet professor, right? Different skills, or a musician, whatever. There are different skills needed for different areas, but you have to want to do it, because somewhere along your way, you're going to come into really bad troubles. And I used to see this for every single grad student that I ever knew. They always had a crisis somewhere in their graduate career. There was somewhere where they couldn't get past an exam, or they get into the lab and the equipment won't work, and the equipment, you know, things, and they start questioning, was I cut out to be this or not? And the ones that succeeded were the ones that said, I'm going to go try again a different way. I'm going to, you know, I'm going to take a little break, and now I'm going to go and I'm going to do it again, and I'm going to make it work. And the ones that go, I don't know, they dropped out, you know. So you have to want to do it, and you have to have the confidence in yourself and your skills, and then you got to go and find a niche where you fit great. But many people do it. It's not impossible at all. It's really straightforward.
Has he scared you? Has he put you off?
You're supposed to be scared a little, but
supposed to be scared a bit.
But determined now.
Good. Please, more hands. Yes, please. Here. Could you have the? Oh, sorry. One microphone here, and then yes. Sorry, there was somebody here. Yes. Oh, sorry. Oh, okay, and you, please. So, and the microphone to this lady here as well.
We're only going to do the right-hand side of the...
Well, I was trying to, yeah.
Thank you very much for the very interesting presentation, especially for Catherine. Given that you fought against disbelief so early in your career, do you feel that perhaps scientists have to communicate even better and perhaps at a lower level so that they don't get the backlash that people are experiencing against mRNA technology? Just like Galileo would have been burnt at the stake. It becomes...
House arrest.
I know it's a difficult question because you're focused on finding the truth, but some people will not believe the truth even if you show it to them. And how can we move society forward so we don't create these conflictive environment against science? And it also goes to cosmology. There's still people believe that how can we spend money on these wonderful questions that you're solving, and yet we're doing such a poor job at keeping our planet whole and healthy.
So, Katalin first, please. Thank you very much indeed for this very provocative question. It's very good. Thank you.
Yes, so you know that what you have to understand, and the people have to understand, that the scientific process. So, you know, when they told me, oh, one scientist say that, other scientists say something else. So we shouldn't believe the scientists, they don't know. And what scientists we should believe. They have to understand that this is a process. I remember coming to the United States then, and Duesberg was a famous virologist who said that HIV is, there is no virus is causing AIDS. And you know that some scientists say that, and then because they could see that there is not fully proven that it is virus is causing AIDS. And then more data is generated. This is how science works. So you know that you collect data and prove one way or the other. So, you know, you have to understand the science is a process. And eventually we will learn the truth. But what we are used to it is the politician. Oh, the politician is say, this is how things. This is what people like to hear. That's, you know, the facts. That's how it is. And not saying that, could it be different ways? And so definitely we have to educate the public about that the scientific process of, you know, people thought that the earth is flat. Of course, you know that go up in a space and you can see that it is not flat, or you can walk around and you see it's not flat. So that there is a scientific process which will learn the truth. And what happened here in, you know, the hesitancy about the vaccines is that people always were afraid of unknown. Even 100 years ago, they didn't read that 100 years ago when the diphtheria vaccines were distributed, the people behaved the same way. They were not grateful to those who gave them the vaccine, and if something happened a couple of months later to them, they blame always on the vaccine. That was already 100 years ago. Just there were social media.
But just on the really focusing on this question of whether we have to go more basic in that education. You say that we have to educate people about the scientific method. What is your experience of people's reaction to the vaccinations that taught you about how to get the message across? Is there something that you've learned about how we can how scientists should talk to the public from the recent experience with COVID?
Yes, as Mara mentioned, that we use this term, which is very technical. And what I have seen, like I have seen a video, a cartoon, and you don't have to explain who is the virus, because that was ugly and black, not like everybody's making in this corona in pink and one. No, it was angry and black, and then you could see that the vaccine was delivered, and you could see the immune cells were very brave, and they are running around, and then they are finding those bad black viruses, and so it was a very simplified way of understanding that who is the good guy and who you have to root for. So there are different levels. You can have it as a school level, you know, and then you can have a higher level of explaining, but you don't have to use specific terms if you are making the characters obviously who is the bad guy and who is the good one and how it works. So these cartoons I found helpful.
Thank you. And George, very, very briefly, because I want to go on to the next question. How would you defend cosmology?
How can I be this brief when I have so much to say? Especially why I want to end with a positive note, because some of the stuff I'm going to say, there is only one Hindu thing that I like and I relate to. Much of the other stuff I have some difficulties with. But it's Shiva dancing on the immortal dwarf of ignorance. right? And signaling with his hands, or her hands, depending on which state she was in, that it's okay for humans to proceed with their business because he's standing on, on the dwarf of ignorance. And we're not quite where we're standing on the dwarf of ignorance right now. But I was saying at lunch, part of my theory that he was referring to, my theories of everything, is that we're actually entering a new renaissance. If you remember, before the Renaissance in Europe, if you studied a little history, there was a lot of belief in witchcraft and crazy, really strange ideas, not so much in logic and that people could be good and that reason could triumph over things. And we are living in an amazing time right now. We have tremendous advances in science and technology. Your life probably is much better than the life of your forebears, right? We had a great lunch during this time. I was still in my 30s. It's shocking to me we're doing that when the planet's being ruined. I can't reconcile the two things going on at once. How can we be rushing right up to the edge of the cliff? And how's that going to work? Well, if you have the real Renaissance, you're going to figure out how to fix that. And part of that problem is to convince people that rational behavior and making things go forward is going to make things better. And that particularly the people who are wealthy are going to be able to afford medical treatments where their life expectancy is going to get much longer. It's a interesting human epoch we're entering in here. And the fact is, there are people there who don't want, they are the dwarf of ignorance. They don't want to be stood on. They want to stand up and say outrageous stuff. And it's a compassion, it's a competition now between the people who are being rational and try and get people to being rational and trying to come up with a world order that will keep the environment from running over too large a fraction of the population, right? I think it'll be a sixth of the world's population that's going to suffer very severely. It's a tricky time we're living through, but it's, for the people who do the right things, it's going to be not bad.
Thank you very much indeed. Sorry, I'm just going to bring this next question in. Please, there was a lady here.
We're going to go the other side of the aisle?
Yep, we're going to this side. And then we'll go back there.
Thank you very much for a marvelous conference. I had a very brief but very deep question. Right now, we're witnessing for the first time, rather, that technology is providing many answers, which is kind of undermining our capacity to question things over and over again. I don't know whether you feel that way or that you notice that trend, and how do you feel it would unravel into the future? Thank you very much.
That is a very deep question. George, do you want to briefly tackle it? Mara, we haven't heard from you for a while.
Let me quote Nora. Where's my housekeeping robot?
How does your housekeeping robot stop you?
Where is my housekeeping robot that's keeping my house or apartment clean and shiny and my refrigerator stocked? Where is it? I need it now. It's getting harder to do those things. What part of technology you want to give up? Your refrigerator, or you want to give up,
But is the technology getting in the way of asking the deep questions? Is that the?
I know, but is she willing to give up her refrigerator to know the answer?
Questions. We're just remaining with the answers and not going deeper.
So are you saying that technology is undermining curiosity?
A bit.
A bit, okay.
It's undermining our ability to understand the world around us because our technology is getting so advanced in some areas that we no longer do it. When I was young, I could take my car apart and put it back together. I couldn't possibly do that now.
But
I don't have a car,
but the supporters of technology would argue that it is taking the burden off certain things. Your car now runs itself, so you can apply your curiosity elsewhere.
Right. So the question, it really comes down to, what is it to be a human,
And what should humans be applying their skills in intellect for? Yes?
However, I think that if I get your question correctly, sometimes, especially for some specific fields like bioinformatics or whatever, we tend to gather data but without really getting insight into that. So I guess your question goes more into that direction. However, if I would say something is that it depends on how you use the technology. So the problem is not in the technology. The problem is how we, as humans, as you were saying, are using this technology. So if you, instead of using your memory for whatever, no, for remembering things or data or whatever, you are subcontracting this to your iPhone or to your computer or to Google or whatever, then of course you will lose your capabilities, right? But it depends on how you use it. And I agree with them. I don't think that this will harm curiosity by itself, but it will if you are trying to do science without thinking about what your data are telling you, right?
And Katalin, thank you very much. Katalin, you've already touched on this.
Also, you know, that I can understand that it's alienating. You know, you can see in medicine, you know, the doctors order this kind of MRI, then X-ray, and this and this. And somehow, you know, nobody's talking to you. You know, you just get those data that, you know, about different technological things. That's happened to me also. And none of the doctors looked at their, okay, so what's wrong with you, you know, kind of thing. That's how I felt, that all of this technology was there to look through me and do PET, CT, everything. And nobody was talking to me.
Thank you. Thank you very much indeed. Well, I think that question may be continued to be talked about as we go to the reception in 5 minutes' time. Questions are beginning to fly everywhere. We have one here. I see you there. Yes, please.
Thank you for the conversation. And above all, I think you are very good teachers and very good presenters, and not only very good scientists. I have one question, which is, what keeps you alive at night? I mean, you said that being a scientific means to have an obsession. What is the obsession that now keeps you thinking and working? What is, I will say, the core issue? Is the small, or is the large, or is the circular, in the case of Catherine, or is how you can change illness, or whatever. But what is, well, with Professor, you have so many theories that I suppose one is your obsession. No, you don't have, you are not obsessed by all the themes that we can follow. And again, thank you for the conversation.
It's a beautiful question. Thank you very much indeed. Well, let's do very briefly, and then we can have one more question from the back. What obsession keeps you up at night these days?
Yes,
Katalin.
I can say that, as I mentioned, during those years, I feel that I understand the disease and I have a solution, and people are suffering, and very easily can say any invitation I got for this Nobel Prize to say no, because I am thinking about those people who are suffering, and I feel that I can help. And then constantly what I have to do, because I will be 70 years old in January, and you know, time is limited, and I feel that I have to help. And that's what I don't sleep well, actually, 2-3 hours, and I wake up and I have to something arrange to get this clinical trial ongoing.
And I can testify to what Katalin just said, because I keep on asking her to do things, and it's very hard to get at any time. And getting these hours with you now has been a joy. So that gives me an excuse to give special thanks to Katalin for being here. Thank you. Mara, very quickly, what keeps you up?
So, in fact, what has kept me up at night during many, many years is how is it possible that from this bunch of cells and molecules, ideas and your mind comes out. How is that possible? How does it work, right? And I think, for me, neuroscience is the most fascinating discipline to dedicate. So understanding the brain, Woody Allen was saying, the brain is my second favorite organ. So it's my first. No.
That's taken the conversation in a whole new direction. Thank you, Mara. George, very briefly, your obsession.
Oh, this is hard.
But no, it's difficult. After what Mara said, one's nighttime obsessions, one doesn't want to go there, right?
So I worry about a problem I've worried about for years, but now it's grown like an octopus with octopuses underneath. And it's, where did all the information in the universe come from? Because if quantum mechanics is right, information is preserved. So all the information for all the stuff that's here in the room existed when the universe began. And there's a lot of other stuff, but we also have a reason to think there's one less dimension than we think we live in, that we live in only 2 spatial dimensions instead of 3. But the information is all still there. That's what works out so great. But then what does it mean to be a human when it's clear to my instincts we live in 3 spatial dimensions? So this is what keeps me up at night, because as soon as I start thinking about these, it radiates into a huge number of areas, right? And if quantum computers work, then this is all a really relevant question.
That is a problem that probably doesn't plague most people in the audience at night.
That would keep you up at night.
Exactly. Now you've upset me. Right. Last question. Thank you very much indeed from the back, please.
Hola, quería preguntar.
Hello. Let me begin by saying thank you so much to Katalin Karikó. Thank you very much. As a journalist, I wanted to say thank you, and especially ask Katalin Karikó, because she mentioned the work of scientific journalists. I am a scientific journalist. We try to make your science something familiar to non-expert audiences. So I wonder, up to what point, when you achieve this degree of excellence that you have achieved, the 3 of you, how can you actually encompass these interviews that journalists perform, quote unquote, on you? How would you deal with that?
Thank you very much indeed for the question. This is a question from a scientific journalist who is asking, in relation to the conversation about simplifying information, when you're interviewed by a scientific journalist, and it's a specific question for you, Katalin, how do you cope with explaining what you have done to a scientific journalist? What is your method for getting the message across to scientific journalists?
I usually state that I did not invent the mRNA. Nature invented, and I explain also that the coronavirus is a mRNA. It has a mRNA and codes for many different proteins, and as a vaccine, we just select one little piece of this coronavirus mRNA, which will help to teach the immune system how to recognize the real virus.
That was a beautiful description. It was really nice. We should just capture that as a little bit of YouTube video and put it out there for everybody. Well, nicely done. A nice finishing point. I know there were lots of questions that didn't have time, but now we have a lovely reception where we have the chance to talk about all these things. And so please come and ask your questions to Mara and George. And I would like to thank everybody for being here. I'd very much like to thank the audience. Thank you all. And of course, Raimondo and the Foundation for hosting us. And particular thanks to Katalin, Mara, and George for being here. Thank you all very much.
Thank you.
Ok, Katalin. Familia, tienes que dejar ese puesto, ¿vale? El de los logos. Thank you very much.